I'm going to try something a little different with this video in that I'm going to interject as the conversation flows with clarifying points, items to review, to look deeper at, to better understand by me explaining more fully what's being discussed. In the second half of the video, where we're talking a lot about hardware, I will pause that conversation to throw in a video showing exactly what it is that we're talking about and clarifying the speed at which the conversation was had, because it was pretty quick, even though it was quite a long conversation. I want to be sure that at the end of the conversation, at the end of the video, you know exactly what was being discussed, because it's a fairly common application. So let's talk about the client's application, and then we'll fire up the conversation. We'll talk about what their application is, and then fire up the conversation. Let's do that now. So what the client's building is a 4-foot by 8-foot door. That door is going to be 2-inch by 2-inch, and what he sounds like he said was 3/16 solid steel. It's unclear to me if the door is going to be a single light or multiple lights, but later in the conversation he says he's going to be using 1/2-inch glass. So I'm thinking it's a 2-inch by 2-inch steel tube, two rails, a top rail, bottom rail, 2 stiles. And by the way, if it was me, I would be mitering those intersections and then welding the face on both sides is what I would certainly be doing. Welding that outside corner, welding the inside corner. I'd want that to be all sealed. I don't want any moisture getting in there at all. No direct moisture anyway. 1/2-inch glass, if I haven't already mentioned that. And the conversation starts with, the subject line of the email is balanced door on an Ives 7256 pivot hinge. And we're going to talk about what a balanced door is. We're going to talk about what that pivot hardware is and how to prep for it and the other hardware that we get into. So the client's concern was, how balanced does the door have to be on the hinge, meaning the pivot? Well, the 7256 is a center hung pivot. There's an imaginary line that goes down through that door, 4 foot wide. What he wants to do is take that vertical axis of pivoting and not install it at 1 3/4 like the template says, but move it over to 12-inch. Turns out that's not only okay, it's a good idea. The factory will literally say moving the pivot point over helps distribute the weight more evenly on that pivot hardware. The client was quite concerned that that would be a problem. It's not. The closer you move it to the center, so it's like a revolving door, the better able the hardware is to simply handle the weight of the door. The client says, I plan on having the hinge, the pivot, about 12 inches in from the jamb. So would the door have to be weighted evenly on one side? I'd have to add weight to one side of the door. The door will be approximately 300 pounds. I have to add about 75 pounds of weight to the short side of the door. Also, none of that. Don't do any of that. Also, I'm confused to the top center pivot's installation. What is the size of the mortised hole for the top section? It's 1 5/8 deep, and how deep? The edge of the sides to be screwed into the top jamb are supposed to be 1/8 inch deep. They're deeper than that. What is the length and width? So the client's probably looking at the Ives template and what's going on here. And like I say in the conversation, sometimes the way the Ives drawings are, they require more staring at it, or maybe even calling the factory, which I've had to do in the past. Let's fire up the conversation and let's interject as we go along. Architectural Builder Supply is pleased to present you with this recording of the technical question that is listed in the title of this video.
This call may be monitored and recorded for quality assurance.
Oh, yeah, sure.
Dude, I'll leave you all the reviews you want, man. You're the best.
Yeah, okay,
well, best, dude. Serious. I saw you online. I'm like, man, that guy knows what he's talking about. So I decided to call you.
Yeah, awesome. I'm glad.
Sure.
It'll be a win-win. So you're working on a... Bear with me one moment. Let me catch up to where we were. Was that an Ives 7256, maybe?
Yes, 7256. Yes.
Yeah, balance door. I bought
Yep.
a pivot making a door. Yeah, cool. Square steel tubing and glass. How balanced does the door have to be on the hinge? I plan on having the hinge 12 inch from the vertical axis of pivots 12 inch over 300 pounds. Okay, so well you sure have enough pivot for 300 pounds. At 7256 is rated for 600 pounds. One might argue that you've got too much too much pivot. So now let's talk about that. The 7256 is really meant to be poured in a bed of concrete.
So what that means is the underside of the pivot has studs coming off of it, 4 posts or studs. There's no holes drilled in there for you to run wood screws or machine screws down through the base. And the reason is because when you get into these heavier weight capacities for pivots, 600 pounds, 1,000 pounds, grade 1 screws are not sufficient to hold that door at all. That door is just simply too heavy for that type of mounting. So what you'll see are those studs. Ives has it, other manufacturers has it, and that you're meant to break out the concrete once you've got it positioned where you want it, and pour mortar around that. Now I know that there have been people that have removed those because you can unthread those studs, at least I believe you can, and then run screws down into it. I know people have done it. I've not had anyone report back to me that it doesn't work, but this is meant to be poured in concrete. And there's not a lot of mention on the installation instructions of the 7256 bottom, other than it refers to, and I'm looking at the note, top surface of cement case to be flush with the finished floor. So cement case. You're not going to have a cement case when you're physically screwing it down to the floor. So be mindful if you're looking at a 7256, unless you're going to deviate from the way that the manufacturers built it, it's going to be poured into concrete. And realistically, that's not realistic for most installations for most people. This client, well, let's hear what he says.
Yep.
Okay, there you go.
Yep.
Okay. Well, then, if that's what you're going to do, then that's the best pivot for that, because the alternative manufacturers would be more expensive, I believe, than an Ives 7256. So, it turns out when you move the vertical axis of pivoting further towards the center of the door, the easier the job on the pivot gets.
Really?
Yeah. Actually, it's encouraged. So if you've got a door that's like you don't give. So how wide and how tall will your
So
door?
it's about 4 feet by 8 feet.
Oh, okay, yeah.
So 4 feet wide, 8 feet tall.
Yeah. So the manufacturer's catalog is definitely going to have that 600 pounds engineered for a door of that size. So 408 is not. It's a large door, but it's not. We're not talking 6 by 12. So
Right.
And yes, as you move that vertical axis, you could turn it into a revolving door. Move that pivot point right down in the middle, or 12-inch over, and it's going to work now. It's going to work out really great. Is this an exterior door?
Yeah, it is. It is.
Okay. So the challenge with doing a center hung, which is what you have, is of course weather stripping the unit. So
I know, it's so pain in the butt.
Yeah. So the moving the vertical axis of pivoting over is actually advantageous. It's very common, and it's funny you say balanced door, because that is, I wouldn't call it a balanced door because of the way that a true balanced door articulates.
So the client used the term balanced door, but I don't think they were using it in the technical way that it's a balanced door, except they were, I think, talking about balancing the weight over the pivot, but there's actually such a thing called a balanced door, and I refer to it. So let's take a look at what an actual balanced door is. And once you see these, you'll say, yeah, I think I've seen those before. Maybe you haven't. Maybe you've not noticed it, but they're interesting. So let's take a look at them. So we don't have a lot in our site about balanced doors because we don't sell them. But C.R. Lawrence, they have balanced doors. Probably from whatever company that they bought that made balanced doors. Yeah, so balanced doors. And by the way, very particular code requirements on balanced doors as well when it comes to egress. So a balanced door, the tip-off is that it's got some sort of interesting gizmo, some interesting hinge gizmo. Balanced mechanics. The door pivots on 2 single cast bronze or stainless steel arms located at the top and bottom. So the door pivots on 2 single-piece cast bronze or stainless. These are attached to a pivoting hinge tube that runs the entire height of the door, and it's part of the door design. The hinge tube contains a torsion bar that provides the closing force to the door and is connected to a hydraulic checking device located in the header and a tension adjusting gearbox at the sill. So really a unique animal, and this is exactly what I'm trying to describe. The problem that we have in our business when it comes to door closers is that we need to contend with a closer possibly having to be compliant with a reduced opening force, which is in our industry 5 pounds of force. 5 pounds of force to push that door open. That's a very small amount. And as a former leader of the technical department at LCN once said, you know, Rich, with a reduced opening force comes a reduced closing force. So you can have air pressure conditions within the building that this air is trying to escape out, but the poor closer with its reduced closing force can't get it to close. Can't get it to close. Okay? In an instance like this, where you're drawing air into the opening, you might find it difficult to pull the door open if it was hinged conventionally, because the entire surface area of that door is trying to pull back against that vacuum-like condition. So a balanced door, what happens is when the door is in the closed position, this opens up slightly over here, but it opens up a lot more on this side, allowing air to come in to equalize better around the general area. When our balanced door is open, approximately 2/3 of the door swings outward while 1/3 of the door swings inward, allowing wind or stack pressure to assist rather than hinder the operation of the door. Air pressure balances itself out around the rolling pivot, so less force is needed to operate the door. That not only means pushing it open when it comes to a stack or pressure condition, but also getting it to just close. Okay, really, really important when you're dealing with handicap or ADA compliance. Okay, this catalog you can go through if you were interested to know more about it. You know, this is, you know, you see these in Class A office buildings, the front of hotels, tall structures where they've got an enormous amount of HVAC happening on the inside of a building. Balanced doors will really suit those requirements, and they can be made, and I've seen them generally in very beautiful sorts of derivative options like this. Probably the front door of a church with the doves. Religious iconography is not an area of expertise, but I'm just going to guess that it is. Yeah. Doors made of bronze. You'd see bronze doors like this on above-ground burial vaults. They used to call those bankers' boxes because in the Gilded Age, only bankers could afford them. Yeah, really neat. Pivot arms. Okay, let's continue on with the conversation.
But you're kind of emulating that. And the purpose of a balanced door is to help neutralize any sort of built-up stack pressure inside of a building so that the door is easier to open, but more importantly, the door is more controllable in the closing cycle. because as you push a balance door open, the pivot side starts to crack open in a weird way, and it allows airflow to move. So that's what you're doing, and I understand why you're calling it a balance door.
Yeah. So I don't know if you call it the balance. So the center point is going to be like 12 inches from the side, not the center.
Yeah, I understand. Yeah.
So,
and in this case,
so
it's actually 12 inch from the center or from the end.
Okay. So, in this case, yes. So it doesn't have to be, like, let's say I'm standing outside and the small section of the door is going to be on the left.
Uh-huh.
Do you know what I mean by small section of the door?
Yeah.
Like pivot point. Okay. So I don't have to put more weight on that left side?
Absolutely not.
It's so weird because the way the piece looks, like it would just rock off of the pivot point if it was weighted more right or left of that pivot point.
No, definitely not. No, because that...
So to address the client's concern, and the client does have a concern here, because he continued to mention it, and I wanted to illustrate why there is no concern. And this isn't an Ives 7256. It just happens to be a pivot that's right there on the shelf behind me. So, as all true hardware people may admit that they're lazier than many of us, the less work the better. This pivot, when the bottom arm is installed onto the bottom of the door and it sits on that floor plate, there is no potential for lateral movement, none whatsoever. That is locked in together. The only way for this bottom arm to move is to lift that off the door. That's the only way it's going to move. You got a simple male and female sort of arrangement here. No lateral movement at all. The way that you actually will operate this is, and I'll be mentioning it in a moment, that top pin, when you drive that up, you can see I'm pulling it up. Okay, this is going to get up into the header, and then this will be in the door itself. And the only way to get this door in and out is with the pin pulled in. Mortise to the top of the door, mortise to the bottom of the door. This is sitting on the floor plate. This is like this. The only way to make this move is that you take the door and you place it on the bottom floor portion, place it down, and then tip it in, and you've got it rotated open, and someone else is up there with the screwdriver up in the header, and they're turning this walking beam top pivot such that is going to lock into the header portion. The top pin is going to go into the door portion. Now there's just no way that it's going to move like this at all. It can't move like this at all either, because the only amount of play you got is the margin from the underside of the header to the top of the door. Yeah, it'll move 1/8 of an inch if you do this to it, but that's the only movement that's going to occur on this. Let's continue on with the conversation.
The bottom arm is going to sit into that thrust bearing. Well, it's not a thrust bearing, but the female receiver that's basically attached to Mother Earth. And when you take that door, you've got the bottom portion in the floor. You've broken out the concrete. Okay. You have applied some means by which to place the floor portion so it's true plumb level and square. You're filling it with mortar all around. You're going to let that set. And then when that bottom arm gets attached to the bottom of the door and you set that on top of there, the only way that it can come out is being lifted straight off.
Really?
Yeah. It's not going to slide at all.
Okay.
No, sir.
Because I was trying to calculate, okay, well, the right side of the door has, it weighs 25% more. And so I was going to offset it by putting weight into the very left frame of the door. Because it's square tubing, so I can put extra steel in there, basically. But that's not what I need to do.
No, sir, not at all. When you get the top pivot installed and you draw the top pin down from the header, it's going to lock into the the male of the header is going to lock into the female of the door portion at the top.
Yes.
And the only way to get that sucker out is to retract the pin up into the header, tip the door forward, and then lift it straight off the bottom. There will be zero lateral movement on that. Zero.
So interesting. So interesting. Oh,
yeah,
by the way,
awesome.
on that top header, like, what are the measurements of how big I make the inset hole to put it in? I was very confused by that.
What we're going to do now is actually illustrate how I would prep for that top pivot. And the same logic goes for the header, the bottom arm, whatever it really is. And we're going to use a CAD CAM software for doing that because it will allow us to visually see what's happening. So let's switch to the screen view. We'll take a closer look at the template, and I'll use it to build the CAM, actually the CAD portion of the software in order to show you a toolpath. Let's do that now. Okay, so let's look at the 7256 top. Actually, yeah, this will work perfectly. So what I'm attempting to illustrate to the client is how they're going to prep this using a body and plate preparation, that terminology. What's a body and what's a plate? So a good way to do that is to simply illustrate that. And let's pull up some software here. Create a new file. And we're going to say that this is, yeah, 10 by 10 is fine. Our material thickness, and I realize that this is outside of what you would normally be seeing, but I'm going to set the material thickness to 3 inch. It's almost an arbitrary value. Material thickness, our datum will be the lower left, our resolution will be high. Okay, so in this drawing software, I'm basically going to take a look at what it is that I'm drawing, and what I'm drawing is the header portion of what I'm going to prep the header for. I'm gonna take the header portion of the top pivot and I'm gonna prep the header for that. Now, if I was actually doing this on my tool, I would be doing it this exact way. So let's first identify what that top pivot looks like based on this drawing. So the header portion is going to be a total of 5 1/4 wide, 5 1/4 wide, 1 5/8 deep. The body prep is 3 5/8. You know, and it's going to be positioned at these locations. This material is 3/8 thick. So let's draw the body prep. The body prep is going to be 3 5/8. It is going to be 1 5/8 deep, and then it's going to be 1 inch wide, and they're showing it frame leaf. They're showing it here, 1 inch wide. This is looking down through the top of the header, 1 inch wide. Now, what's important to know is the header portion is a bit easier because we know the client is doing 12 inch from the jamb to the vertical axis of pivoting. That doesn't matter for us in the sense of we're just going to draw how we would tool path this. It will matter to the client in the sense of knowing where to do the door portion. So the bottom line is if he's 12 inch from the jamb to this center line, he's going to have to go back 1 5/16 to start the top of the door prep. And then that's 4 5/8 wide. So let's pull up our drawing software again. I'm going to take this template and put it on a different monitor so that I can see it as I'm drawing. Okay. I'm going to bring a guideline here. Just put it out at, what's our material width? 10 inch. So we'll put it at 5.5. And a lot of this isn't going to really matter to you in the sense of what I'm doing. What I'm doing is creating guidelines so that I know what I'm going to prep. So I've got 2 guidelines that are 1 inch spaced. I'm going to bring in another one. I'm going to bring it down to here, and then let's put that at, doesn't matter where I'm putting it at, 10 inch. We're going to put it at 7.5. Then we're doing the body prep first. Then I need a new guide relative minus 3.625. Create new guide. Okay, that's our body prep. Okay. Close. Now I'm going to bring in additional guidelines for my plate. This is my body prep. This simple rectangle is my body prep. I'm going to give this a vector. Actually, I'll give it a vector now, meaning I'm going to give it actual definition. Okay, so this should be 1 inch, and it is. Then it should be 3 5/8. And it is. Okay, so that's 3 5/8. So what I've drawn here is a 3 5/8 long rectangle, 1 inch wide, and that's going to represent this body prep. 3 5/8, and then 1 inch wide, according to the template. Okay, now I'm going to want to put this vector on a different layer. Call it body. Oop. We'll call that body and that plate. Okay, so let's move to layer body. Up in our layers, we can turn off the body and turn it on. Our plate is turned off. Now let's draw a plate. Let's just draw a plate. And that's going to be, bring back our guidelines. Now the plate, according to the template, needs to be 5 1/4 wide. It's the same 5 1/4 long. It's the same 1 inch width. And the depth doesn't matter just yet. It will, but it doesn't matter just yet. So it's 5 1/4. But really important to know that we have to establish our center line to the end, and it's 1.5 inches. It's 1.5 inches. Let's take a look. And this is a typical error that you see, not necessarily error, but this is a typical, no, actually no, it's not an error at all. It's actually just perfect. So yeah, 5 1/4 minus 5/8 minus 3 5/8 is 1 inch. So from the pocket prep over to this guideline that I'm going to create, what I guess the word error is a bit strong, but that dimension line you know, I'm not sure what they're referring to. What's this line? What's this line? This whole line probably needs to go. This line is wrong. Why that's being drawn there? That's confusing. So we're going to need a guideline 1 inch above our body prep and then 5/8 below our body prep. I'm going to show you why. And it won't be obvious until we toolpath this. So create a new guide relative, -1, and that's what it is. Create new guide. Oh, no, I'm sorry, not -1. It's actually +1. Create new guide. Close. This guide we're going to get rid of. Now, this guide, it's 5/8, and you're not looking at the template, but I am. So it's -0.625. Create new guide. Close. Okay, now we've got these two other guidelines. So I'm going to draw a new vector, but let's go to layer 1. Let's eliminate this vector from layer 1 because I don't want to see it. I want to create a vector for only the plate. There's our vector. Let's take this vector and let's move it to the plate. Now, on layer 1, there's nothing. We're on layer 1. We remove the guidelines. There's nothing drawn here. We move to the body. What happened to our body? Let's move to layer body. Okay, let's take this, let's copy to layer plate. Now it's on the plate. Oh, you don't want to do that. Alright, we are only showing the plate layer. Let me bring my guidelines back because I deleted something a bit too quick. We are on the plate. We can only see the plate. We're going to delete that vector. We're going to create our plate vector. Okay. Our plate vector is highlighted. There's our body vector. On layer 1, there's nothing. The body is on the body layer, and the plate is on the plate layer. Okay, now we can look at these tool paths, how we need to look at them, meaning one at a time. So let's turn on our body. Let's create a tool path for the body only. I'm going to pin this. I'm going to do a pocketing profile, which is what this is. Our start depth will be 0. Our cut depth is going to be 1 5/8. And that is the depth of the body, if you recall the template. It's right here. Okay. Move this out of the way again. Inch and 5/8 deep. The size of the tool is important. I've got a 1/4 and an 1/8 inch end mill here. I wouldn't want to use either of those. I would want to use like a 1/2 inch or a 3/4 end mill. There's a 1/2 inch selected, so let's apply. Let's select. Let's delete the end mills that we're not going to use. Remove. Remove. So we're going to start at 0, which is the top of the material surface. We're going to cut 1 5/8 deep. We're going to do, it's set to 5 passes. Let's just leave it at that. It doesn't matter. And the rest of this doesn't matter in the sense of the setting, because we're actually not going to run a tool over this material in terms of what a safe Z location would be. Do we need to lift the tool? Are we ramping in? It doesn't matter. Whether we're offset or rastering doesn't matter. Climb or conventional cutting doesn't matter, because we're not actually cutting anything. So I'm naming this toolpath body, and let's calculate that. No vectors are selected. Got to tell it what we're doing, and there we go. Now it's given us this gizmo. Awesome. Let's leave that gizmo for right now. Let's turn off our body prep. Let's turn on our plate prep. Let's unselect body. Now, let's create a toolpath for this. Now this body depth, or the thickness, for the plate, having a little problem sliding this file over. Here we go. It's 3/8 deep. It's 5 1/4 overall length. It's 1 inch wide and 3/8 deep. So let's go with that. So we can close this. We're now going to create a pocket profile toolpath. That's going to be 0.375. It's 3/8 deep. We can't use a 1/2 inch end mill. That's not going to work. So let's select 3/8. Do we have a 3/16? Let's go with 1/4 inch. Let's go with a 1/4 inch end mill. Select. Let's remove that 1/2 inch end mill. Again, rastering or offsetting, climb or conventional cutting, ramping in, doesn't matter. We're going to call this plate. Calculate. All right, now it's calculated a toolpath. Now, I have my body and plate toolpaths set up in my cam. Now the fun part. Let's select all of these, and let's preview all toolpaths. I'm going to slow the speed down. It's simulating the toolpath, but bear with me. Okay, now we're in preview. Let's reset the preview. Let's unselect these. Let's preview all toolpaths. Okay. So my software just modeled that toolpathing. Let's reset the preview. Let me slow it down. Now it's literally doing the body prep with the 1/2 inch end mill, which is 1 inch wide. And it's cutting it in the way in which I told it to cut it. Now we are at 1.3 inch deep. I can see that on my tool. Now we are at 1 5/8 deep. This will be the final pass. Now it's creating the plate. It moved to the plate prep. It's doing that little tab for the top of it. My software seems to be a little stuck. Oh, you know what it's doing? It's, okay. It's literally prepping over this area where there is no material to return. That's why you don't see the toolpath. When it comes back down, it'll do the same thing. So now it's stuck there, but it's not stuck. It's just mortising over wood that doesn't exist because we removed it in our body prep. That's okay. I would get smarter. I would create different toolpaths. Prepping that. All right, now the simulation's over. Now let's take a look at, let's move it in 3D, 2.5D space. That's what it's going to look like when he preps it. That's what it's got to look like. If I was literally doing this job, I would be fixturing the wood down to my CNC router, and this is what I would be doing. that is the perfect, well, potentially the perfect prep for what he's doing. Now, I used a 1/2 inch end mill. Is a 1/4 inch radius good enough? Is it tight enough? Meaning, is it going to cause us a problem with our hardware here? And it might. I might have to go back and use a smaller end mill, a smaller diameter end mill. But the purpose of drawing this toolpath was to show you in what's called 2.5D what this actually looks like. I believe it's called 2.5D. Even though it's 3D, I'm not expert enough yet to be able to tell you what it actually is supposed to be called. Let's run that one more time really fast. There it is. That's really fast. Reset the preview. Preview all toolpaths. Beautiful. There it is. You can see that it's giving me an odd artifact here, and I would have to investigate why it's giving me that artifact. That amount of the wood that's been nibbed out. The software doesn't lie. I have definitely found that. But why is it giving me this odd little notch on both sides? I would have to investigate that. In which I would. But this is what I wanted to show you. 3-inch was the thickness I think I selected on my material setup over here. That's why it looks like that. Yeah, 3-inch thick. And there you go. All right, let's move on with the conversation. I hope that was marginally enjoyable.
You know, what's funny about that is Ives, their templates, they're drawn in a goofy way. I've had to call them and say, so what are we talking about? So, you know, the top pivot that's going to be there, you know, it's really handy to have a tape measure or a caliper and the hardware in your hand. But
yes,
just looking at the catalog cut sheet of it, you know, you're going to have to prep. A body prep of 3 3/4 by 1 inch. That's going to be 1 5/8 deep. And then you're going to have to do a pocket prep that's going to be 5 1/4 by 1, and that's going to be 3/8 deep. So if we're talking about only prepping the wood, the header, let's assume it's wood. It may not be. It's probably going to be steel.
Well, it is actually wood. I know.
Okay.
I have to go through stucco and then wood. It's going to be a pain in my butt. But
that's no good. Yeah, you're going to want to get through that. You're going to want to have enough. Okay.
So I'm basically going to like rip off all the stucco, put a false top there of wood, and then it's going to be great. It's going to be great.
Yeah.
So the body of it, the outside rectangle is 1/8 inch deep, and that's what screws into the wood, correct?
No.
The 3 3/4 by 1 inch.
Okay, so 3 3/4 by 1 inch. So, are you looking at the template of the top pivot?
No, I can be, but
yeah, let's definitely look at that together, because I want you to be able to walk away from this conversation knowing exactly how to prep this.
And I just looked at that thing. Let me get here.
That's a 72
okay, there it is.
POP. That's what that is.
That's the top. Where's the bottom? Or where's it?
That's what.
Oops.
Yeah.
7253.
56, right?
7256. Yes.
Yeah.
Okay, there it is. I got it.
So if you're looking at the template of the 7256 TOP, you'll see that do you see the 5 1/4 inch dimension?
Yes.
Okay. So do you see the 3 5/8 dimension? Right below it?
Yes, right below it.
Okay. So in terms of the way that I would think about prepping for this is it'll be 2 steps. If you were running a CNC machine, it would be called the pocket prep. It'd be called the body prep and then the pocket prep. So what I would do is I would do a body prep. It says 3 5/8 here. I said 3 3/4 originally. It's because, why is that? 4 3/8, 4 1/4. Yeah, that makes sense. Okay. So their template and their cut sheet, their catalog page are a little different, I think.
Right.
So I would be doing a body prep. So first of all, before you prep anything, you're striking your vertical axis of pivoting. So in your case, you're going to be 1 3/4 over from the jamb to that line on the header.
Well, I'm going to do the top before the bottom. I'm better with
a plumb bob.
I think I could make the bottom easier. I think it'll be easier to moor to the bottom end exactly than this header.
You have to do the header first. You must.
Yeah. Okay. Good. Okay.
And the reason you do is because then you're going to get the header installed, the header portion installed, and you're going to drop a plumb bob down.
Okay, so I've mentioned the word plumb bob, or the term plumb bob a couple of times. So if you're installing a pivot, you probably know what a plumb bob is. If you don't, it's just an ancient tool to make sure that something's vertical, exactly where you want it. And I don't think Ives has any provision in the installation aspect of putting the material in that will allow you or help you with that. But let's switch to the screen view and let me illustrate what we're really talking about when it comes to a plumb bob. Since the installation does need to start at the top, let's start at the top. Let's look at the instructions or template, whatever we have here. Okay. Bottom center pivot, top center. Okay, so it's a 7256 top, and this is what we're referring to. Yeah, this document's just not giving us everything we need. That's for sure. Okay, let's go back. Let's look for just a top. So it'll be 7256 TOP is what it'll be. Template. Yeah, this is the one that we're looking at here. So a lot of dimensions, but let's just break these down. So what the manufacturer is telling us is 1 3/4 from the jamb to that center line of the pivot. And there's an asterisk. Pivot point may be varied as desired. Minimum distance is 1 3/4. So we already know that the client's doing 12 inch. Okay, great, 12 inch. So this plus sign, it's 12 inch from the jamb. 12 inch over. How far in it is can be varied, I suppose, and it is varied actually. If we've done an excessive, if a client's done a thick door and they want to have something like an automatic door bottom installed in the bottom, yeah, that center line that you see here of door and pivot. So center line, they want, if the client's door is 2 inch thick, so it's going to be 1 inch from the face of the door here. Face of this dash line is the door, 1 inch. From the face of the door in, 12 inch over. Okay, great, no problem at all with that. So now, what are we talking about in terms of a plumb bob? So I need to refer to Rixson because they have a tool Alright, let's just find it. I don't recall what the part number is. Rixson has a tool for helping you locate where to place your bottom pivot. And we're going to talk about prepping the top pivot in a moment. Okay, yeah, quick spotter. Okay. Yeah, they don't. The quick spotter is for the floor closer. We want the 2604 or the 2608 alignment tool is what they call it. Rickson alignment. Yeah, here it is. Here it is. Okay, awesome. Let's take a look at this. Now what you end up doing with this alignment tool is you're going to stick part of this up into the top pivot, even though Ives doesn't have one. Well, actually not into it. It clamps over it, so to speak. So over the pin that projects down from the top pin, the pin that drops down from the header portion of the top pivot, you would, in essence, and I'm using this as an example, insert the tool, okay? And through the tool is where you'll drop your line for your plumb bob. So the concept is, I'm using this Rickson alignment tool as a means by which to illustrate the idea of using a plumb bob. At the end of the day, what you'll end up doing is getting your plumb bob string right to the underside, just like this line is shown here, to the underside of this, so that you can drop that all the way down. And once that plumb bob gets all the way to the floor, you're literally looking to place it right over the very top of where you're going to place the bottom pivot, right over that center line of the pivot. And a plumb bob is the way to do that. That's how you're going to mark the floor. So when we talk about it having to start at the top, it has to, because there's really no way to position. I mean, unless you can, unless you somehow, you're going to start at the top is what you're going to do. Could you possibly use a laser level, things of that nature? Sure. I have never really used a laser level to place these. A plumb bob is something that every carpenter, I think, has. A laser level, possibly not. Hard to say. So that's what that is. Now, let's move on with the conversation.
Yes.
Okay.
Easy.
So in the underside of the header, you're going to go 1 3/4 inches over from the jamb, and that's going to be the vertical axis of pivoting. The
From
other
the center
dimension,
of the jamb.
you then have to figure out how deep in the jamb you'll place that.
Yeah.
Okay. But the important part is 1 3/4 inches over. Now, there's an asterisk on the template. Pivot, so that's number 5. Pivot center may be varied as desired. Okay, that's fine. So what they're actually saying there, it's 1 3/4 inches minus 0 plus whatever you like. And in your case, you're going to either be 12-inch or 13 3/4, whatever you're doing. So your 1 3/4 inches is, the reason I call that out is to say you're going to be 12-inch at that point.
Good.
So you're from the jamb 12-inch over, then you figure out how deep, and that's going to be the plus sign, the crosshairs. That's going to be where that dimension has to be. Then using that as the anchor point, you can see from the template that you've got a body prep that's there of 3 5/8 overall length, and it's 1 5/8 high, and it happens to be 1 inch, 1 inch wide. So you're going to do a prep that is anchored on that 12-inch dimension such that you can fit the body of the pivot up into the header. So you'll do 3 5/8. You'll do 1 5/8 deep and 1 inch wide, and then you go back and do the second prep. And both of these are just rectangles are all they are. And then the second prep is the plate prep. That's going to be the 5 1/4 wide, 5 1/4 long, 1 inch wide. 1 inch, is the other dimension. Your 1 inch would be your Y dimension. And then, of course, that's going to be 3/8 deep. And
3/8, okay.
Yeah. And all you're really doing there is you're notching out the mounting tabs on either end is all you're doing. Because you'll have all...
I know. So, hold on. So the bigger rectangle is going to be 5 1/4 by 1 by 3/8 inch deep.
That's what we're going to call the plate prep.
And
that's the one you do
plate
second.
Prep.
Yeah.
Plate prep. Okay. And then the body of it that's the 3 3/4 by 1 by...
That's 3 5/8 by 1 by 1 5/8.
Okay, I see what they're doing now. Okay, see, this is where I was messed up. And that is the body. Well, I don't know. What did you call that, the body?
You call it the body. And do that one first.
Okay.
You do the plate prep afterwards, just in case if you nick something, you can kind of clean it up afterwards. Yeah.
Totally. Okay, the body. And would you use like a dump plunger, a retractable plunge, or a plunge router for this?
Definitely a plunge router. If you don't have access to fancy tooling, that's absolutely what you're going to use. Absolutely.
Okay, yeah, I don't have a CNC. And it's not, okay. Okay, a plunge router. Okay, that'd be good. I can do those. And then the bottom one's fairly easy for me to do. Because I'm doing the floor anyways, it'll be easy to mount that thing what I want it to be. Okay. The tricky part is putting the arms of the male end of the arms. We'll be embedding those into the square tubing steel frame, because I have to cut out a rectangle in the frame, and then I need to screw that into something. So I'll have to put a smaller rectangle in the frame that will then accept the I don't know what those are called, but the male parts of the hinge need to be screwed onto the door jamb, right? Or door frame, right?
Well, no, your door. The rails, the top and bottom rail of your door. So we've talked about the header. That's wood, plunge router. You've got the dimensions. Your 12-inch. That's you have to maintain that. Now, when it comes to the door, I would get that structure. I wouldn't weld it. I wouldn't put it together until I prepped the top and bottom rail. And
correct.
What I would end up doing, because it'd be probably the only tool I had, is I would take my tube and I would get a die grinder and I would cut that. How thick will the material be? How thick is the steel?
I know, and I can't remember.
1/8 inch, maybe?
I think it's a quarter, actually.
Wow!
It's thick stuff.
Wow!
Maybe, what's in between an eighth and a quarter?
3/16.
Maybe it's 3/16.
Okay, so
I don't think it's eighth. I went one more over. I think it's 3/16 then.
Awesome.
I have to check.
So what I would do is I would get a die grinder and I would just cut my rectangular prep, or I would use whatever tool that made most sense. A jigsaw is probably not going to work because the blade won't be able to reciprocate.
No.
So probably
I have a guy that has a plasma cutter that can do these pretty easy.
Yeah, I mean, if you can fixture that somehow, why not?
Yeah.
If you've got a guy with a CNC plasma cutter, that could be fun.
It is. So, he has that, and so it's kind of fun to give him dimensions. He's like, ooh, and then he cuts them out. Yeah,
fixture it down. I don't know about that blowing. I'm sure that it won't blow through the other side. I don't know much about plasma. Okay, so have him fixture it down, and then cut those two rectangles, and then get a file and clean it. So now you've got a rectangle in the top and bottom rails of the door that your hardware will fall into and sit flush with. Now the question is how do you attach it? And the way that it would be done in a shop is that you would take a piece of steel that would be 7 gauge, 1/8 inch, 3/16, and it would be bent in an offset, like a Z shape. And you would weld that, or you would mechanically fasten it to the tube, and that the ear of that would be drilled and tapped, and you would just screw your hardware to it. So, are you in my website?
So I feel like the conversation gets a bit esoteric in the area talking about how to mount this hardware. So what I have here is what I refer the client to, and it's just a mounting tab. So a mounting tab is a piece of steel that is going to be bent in this offset sort of shape. I have here a typical strike plate. This is what it would look like when it's attached to the door or to the frame. And the concept is the offset is such that it's equal to the offset. The offset is necessary because the offset needs to be equal to the thickness of whatever you're installing and the material you're installing it into, such that it's flush. So you might be able to see here that the offset is too great for this piece of hardware. Well, kick it out the 1/16 of an inch for the thickness of the steel, and now you have a flush condition. So in this strike prep, the same for a top arm of a pivot or the bottom arm of a pivot, as you've heard me saying, I would, one way or another, let's just say I'm going to die grind a rectangle in the tube, and then I'm going to take this tab and put it in the hole, but I'm going to figure out where I need to drill this hole because I would be mechanically fastening to the jamb. So when I look at the top rail of the door, I'll have a hole drilled and a hole drilled, because you'll need a tab at both ends for the hardware. Countersunk, I would mechanically fasten this, and then I would simply drop my hardware in, and I would screw it here, and the other tab would be on this side, and I'd screw it here. These tabs are meant for electric strikes. They're this size. Well, they don't have to be this size, but they can be this size. So that's what I'm referring to with a tab. The client's going to need to make his own because of the thickness of the bottom arm for the pivot and the top arm of the top pivot. So he'll need an offset piece of metal that's going to have holes drilled and countersunk in it to attach the hardware to, and then the other half of the tab you can countersink and screw that to the inside of the steel tube itself, or you'll drill that hole and you'll plug weld it. You're literally going to weld the mounting tabs to the steel, which is what I would end up doing. So what I'd like to do is switch to the screen view and show you a closer look of what these tabs look like, because I can think of an example, what these tabs look like when they're being installed. But it's the same sort of concept that you're going to use when you're thinking about mounting any piece of hardware, whether it be a strike, or a pivot arm, or it be an overhead concealed door closer, or sauce concealed hinges. You've got to have a way to mount that. Now, as I mentioned in the conversation, if you ordered steel doors and frames from a manufacturer, they're going to take their steel, whatever thickness, and they're going to shear it, and then they're going to bend it, and then they're going to post-operation drill and tap it as needed for the application. So let's switch to the screen view, then we'll move back to this conversation. So the manufacturer I think of is Major because they have really nice installation instructions, really big font and lots of pictures. And I know in their templates they always show what these mounting tabs look like. And the strikes that they refer to actually include mounting tabs, and here it comes. Yeah. So here's the prep that you've done. Okay, here's them using a template. Here's the prep that you've done. That template happens to allow them to mark the holes that they need for the mounting tabs. You know, you're not going to have a template. You'll clean out your area, clean it out, file it nice, make sure it's really good, proper for the hardware. Your hardware fits in nice and flush and that it goes inside the space. Then they're prepping, in this case the jamb, you'll be prepping the top and bottom of the door. They're going to screw those tabs because these are aluminum. They won't be welding these to the aluminum frame. So they're going to mechanically hold those tabs in, but you're doing the same concept, where now that the tabs are attached, top and bottom, like he's doing here, You'll then take your hardware, place it in, and attach the hardware to those tabs. So this is literally what it is. Now, a better concept of the idea is a hinge reinforcing plate. So it'll look, I want to use one that has a better photo. Bear with me as we are conducting this search. And a manufacturer who makes the plates that I'm referring to, many people do, I stock them by Donjo. And let's pull up their catalog. Yeah, hinge reinforcements. So let's do a search for that. And the HR-120 is a pretty typical hinge reinforcement. So literally what the client needs to do is to make something that's going to look like that image. I don't know if I have it. Yeah, a little bit bigger photo here. So something that's going to look like this. It's got an offset. It's got the appropriate offset. This HR-120 is going to be meant for a 4.5-inch hinge on a door and a frame that is a standard weight thickness. Now, here's the concept. 3/32 is 0.096. 1/8 is 0.125. 1/8 is thicker than 1/8 is thicker than 3/32. The offset of 134 is less than the offset of 180. The thicker hinge needs a greater offset because of what I was talking about earlier, in the sense that you've got your frame and you're going to cut this prep in it. Well, when you're going to take your hinge and stick it back here, the offset of the tab needs to be equal to the thickness of the material, the thickness of the material, assuming that it's being mounted flush, is the bottom line. I had said earlier you have to add the two together, but you are adding the two together because, well, actually you're subtracting it in the sense that you're mounting the tab on the inside face of the material. So you would need to actually subtract that, which makes sense. I misspoke earlier, and I realize now that I did. If you take 134 and you subtract 3/32, 0.134 minus 1 divided by 32 times 3 is 0.04 inch. Well, 16 gauge is going to be about 0.06, so 20 thousandths of an inch. You are dealing with an extremely small value, a 40th of an inch, something extremely small. So at the end of the day, you're going to be able to expect that your hardware is really going to be flush, is the bottom line. So that's what we're going for when talking about these mounting tabs. All right, let's continue on with the conversation.
Yes.
Okay.
Wait. Where'd it go? I wasn't. Yeah, there it is. Yep, got it.
So in AB Supply, in the search box top center, type in the words mounting tab and hit enter.
Here you go. It's thinking. Okay, mounting tab, I see. Adam's right one.
So all those top two items are, they're just showing you pieces of offset metal. And that's what you have to create to attach this. A couple of pieces of offset metal that you'll be able to screw to.
I see. You could weld one of them. That's why you said the Z. I was figuring, okay. That's actually pretty smart.
So the other way, yeah. I mean, that's the general concept.
Because I was just going to take another smaller tubing, square tubing, and slide it in just there, and it's easy to weld those in, and then you can fasten it to that tubing.
Well, if you can get the offsets correct, if you can
then you'd have to slide in like another little piece of weight. It would be a little tricky, but I figured that wouldn't be too complex. We'll see. It depends on what the guy wants to do for it.
The issue is there's really not anyone who makes custom plates like that.
No.
A hollow metal shop, if they were making me a steel door for this, they would be using a shear and a press brake, and then they would be drilling and tapping, or a CNC turret, or whatever they're using. But mounting tabs are what you have to create. Your hardware's got to be flush, and the offset's the offset. And then you drill and tap, and it's probably quarter 20 for that. Those bolts, I would guess.
Yeah. Okay, this is awesome. I have one more question for you. So the steel tubing door is there's steel posts right to the left and right of it, and I'm planning on the steel post making a latch mechanism that's not locking. This door does not need to be locked, but I do not want wind to be able to blow it open as it pleases. Do you sell locking stuff or latch materials?
Yeah, so you're going to want a roller latch. You can, how wide is the style of your tube?
Style?
Yeah, so when you look at your door in elevation, the steel tube that you're going to use on your two outside vertical stiles, what are the dimensions? We know it's 3/16 thick, but give me...
Oh, it's 2 inches wide. I think it's
2
inches wide. Yeah.
Okay.
And it might be 2 and a bit, like 2 1/4, but I think it's 2 inches. I'd have to check on that.
2 inch, eh?
So I was going to do like a double thumb turn deadbolt, and then put the deadbolt on the actual post, and it goes into the door.
Sure.
Because I don't need it to lock. So that's what I was going to do, and I'm trying to get a double thumb turn deadbolt, which is extremely hard to get because it has to have such a really small back set because it's only 2 inches.
That's going to be Let's talk about that in a second. There are definitely some complications about the hardware. Let's look
a lot. Oh, you do have lock sets. Ooh.
Yeah.
You guys have everything.
So, okay. So a roller latch that you could consider using would be the part number 590-626.
590-626 Redwood 590-626 roller latch with cast strike.
Yeah, so it'll fit in your 2-inch tube.
Oh, rock.
Just barely.
Oh, really?
The problem though is that strike that's there though, you're either going to live with that or you would consider the idea of custom manufacturing one, meaning the roller may start to make contact with the jam post prematurely depending on where you place it. So it may be okay with where it's going to be installed, and it may not be okay. So this tube, is it 2 inch by 2 inch?
Yes.
Okay.
Square.
That's fine. Yeah, that's awesome. So that could be, you might want to use 2 of those, 1/3 down, 1/3 up, that kind of thing.
And the strike plate goes outside of the tube or not flush with it?
It ought to be mortised flush.
Okay.
A lot of people would just resist, they would just surface mount it. You shouldn't, because the gap between the jam or your jam posts and your door, because it's going to be square edged, you're going to have every bit of, I would need to really put it into AutoCAD, but probably 3/16 of a gap minimum.
So it occurred to me that the client was going to need a little bit of extra information, so that's why in the conversation, I'm telling him we probably need to look at AutoCAD. Let's just hear the conversation a little bit further, and then we are going to step into AutoCAD.
I have to radius these things on the small side, which would be tricky, I think.
How are you going to do that on steel tube?
It's going to have a big gap and a lot of weather stripping.
Okay.
That's really what it is. I mean, I will radius a little bit. He'll grind it down, but I don't want to compromise the integrity of it. So it's just going to have a lot of weather stripping, which is, do you sell weather stripping? You do.
Oh, yeah. No, I've got the manufacturer for weather stripping is Reese, R-E-E-S-E. Now, before you decide on what net size to make this, absolutely toss this into AutoCAD. It's simple, because then you'll see it. If your buddy's got a CNC plasma, he's going to know how to rotate something in AutoCAD.
He does.
Yeah.
And I think we did, and it's like, oh, what was it? It was like it needs 5/8 clearance, maybe. I think that was it, which is a lot. Without doing it without radiating it, radiusing it, I think it was 5/8 inch clearance.
It is that sounds that's way too big.
Mm.
Yeah, it's definitely not going to be that size.
That's too big. You're saying?
Yeah,
was it 5/16? I don't think it was 5/16.
5/16 sounds better.
Maybe actually it was, because a 1/2 inch sounds way too big. It probably is 5/16. Sorry, I don't have that written somewhere else, but
that's okay. No, it's just a number you got to come up with.
So you sell weather stripping, my man. And I was going to actually wait for it to be finished and then do the weather stripping just so I can see, because it's so hard to predict. I don't know. I have a hard time predicting everything, but we can do that. So I would be very interested in these roller latches. Do they come in any other? Well, I can just paint them black.
No, they come in all of the architectural finishes.
They come in finishes. Oh my goodness. Okay. So those ones, so the latch, couldn't I just I'm trying to look at that latch plate. How do I manufacture that latch plate into the post without having to fasten the latch plate in there? I'm can I just grind out a little bit of, I don't know, probably not. A little bit of a valley?
Yeah, if your steel was really that thick, air cutting that rectangle is not. I mean, actually, and that I would have tabs for, because that's a standard offset, thickness for that item.
What do you mean you have tabs for it?
Mounting tabs. You wouldn't have to worry about making mounting tabs for it.
Wait, you're saying you just put it on there?
Ideally, you're gonna mortise that thing.
Yes. Okay. Let me ask him, because this sounds like a great solution. I've never even heard of a roller latch. This is really fun. Okay. Let me ask if he can put that in there. What's the deal going to be with that?
Yeah. So I actually have the object drawn in AutoCAD right now. So we're just going to keep talking, and I'm going to end up telling you what it is right now.
Okay. It's crazy. How do you do this so fast? My brain does not work like that.
12. You want it 12 inch from the jam. Okay. So Reese is good. I like Reese as a weather stripping manufacturer because they have polyurethane, and that is really a lot of stuff, abrasion resistant, and things of that nature. So I would suggest that you review what they're doing, and they do have some larger things as well. Okay. So. Now, in terms of a lock body, the issue is going to be you need a really narrow back set, and that's not going to be hard. Yeah, I've got this drawn in AutoCAD. You're going to be able to get by with a lot less. I mean, seriously, you know what it is? Your door is only 2 inch thick. So
Yes.
for real, I mean, 3/16 is, well, no less than 3/16. I would make it a 1/4 inch.
Okay. Oh, wow.
It needs to be a 1/4 inch, but that's what AutoCAD is telling me.
Wow.
So
Okay.
make it 5/16. You know,
Yeah,
no problem with that.
yeah.
You're going to cover it up, but AutoCAD says 1, 2, 3. Yeah, no less than a 1/4 inch for sure.
Okay. That's good. Yeah, I think that's good.
Yeah.
Yeah, and because that's a lot easier to weather strip.
Yeah. No less than 5/16.
There is. I know this is too. I was going to put.
All right, so here is what I've quickly drawn in AutoCAD. It's basically an object that's 4 foot wide, a jamb that's whatever, 5 inches, and I have my XY origin basically at the outside or the lower right corner or datum of the jamb itself. So if you recall, the client wants to put their center line at 12 inch, and yeah, let's take a look. All right, so we've got a 4 foot wide door. All right. Now let's measure how thick this is. How thick the door is, I should say, distance. Because I actually drew this yesterday. It's not quite 2 inch. So let's redraw this door. I don't know where in the jamb they're placing it, so let's just assume that the door is going to be okay, let's just assume that the door is going to be flush with the outside of the frame. And I'm going to place my door a 1/4 inch off of the jamb. So we're going to go 48 inch at 0, 48 at 0, I'm sorry. I have lost what we're doing here. There we go. Line. Let's go 2 inch at 90. Go 48 at 0. Let's go 2 inch at 90. Let's go 48 at 180. Enter. Now, okay. Now we've got a door that's 4 foot by 2 inch, 4 foot wide, 2 inch thick. Now the client, if you recall, wants to put their center line at 12 inch over. So I'm just going to draw a line. I'm going to make it 12 inch long. There it is. And I'm going to give myself a little reference point at 12 inch. I'll even put myself a little target here, 0.75. Beautiful. So now this is 12 inch from the jamb. I'm going to get rid of that dimension, that line, just for the sake of getting rid of it. Properties. Make that a smaller. That's going to be our vertical axis of pivoting. This is what the client wants. Okay, now the question becomes is how much gap do we need? I'm going to move my origin out of the way. I'm going to select my object, but I know that I have to group this first. So I'm going to go over here to rotate, which you can't see, it's just rotate. R-O-T-A-T-E, enter. R-O-T-A-T, enter. Select the object. I've got it selected. Enter. Select your base point. It's going to be right there. I'm going to get rid of... Well, I'm going to put my grid lines back on, and I'll show you why. So I left the 1/4 inch margin on this. Nowhere does it get really close, but the question is how close does it actually get? So let's just get it out to about the maximum, and we'll leave it parked there. Now these grid lines are a 1/16 of an inch. You can see that I don't even get to 3/16 gap. So when I'm telling the client no less than 3/16 or whatever I said, 1/4 inch, yeah, I mean you've got lots of room. So the important part of what I'm talking about is I drew the door with a 1/4 inch gap. I could have drawn it with an 1/8 inch gap. Let's do this. Line. Let me bring a line up here at 1/8 inch. Okay. I'm decreasing that gap. So now let's rotate. Select the object, enter, select the base point. I mean, even at 1/8 of an inch. So giving us the margin that we're talking about, 3/16, 1/4 inch, not a problem. Because with an 1/8 inch gap, you don't really encroach much. You encroach a 32nd of an inch. So you're in really good shape. Thermal bow, having a little larger gap, whatever you're going to do, fine, but you don't need much gap, and it's because this is only 2 inch thick. Now if it was 3 inch thick, 4 inch thick, 5 inch thick, yeah, that all really changes. Or if the vertical axis of pivoting moves somewhere else, that will change as well. So let's go through this as an experiment, just because we have it all drawn. Let's put our dimension at 1 3/4, according to what the manufacturer's template says. 1.75. Enter. Great. Let's give ourselves a little circle right here, 0.25. Let's give ourselves a line. Awesome. That'll be our vertical axis of pivoting. Now, we need to group an object. Group the door, which I did not group earlier. I ungrouped it actually. So let's group this. I don't want to group my dimension lines. Let's get rid of that cheat line. Let's not, actually. Let's leave it. Okay, that's grouped. Let's rotate. There's our object. Enter. Specify our base point. There. Oh, yeah. Yeah. See that? A 1/4 inch is no good. No good. So it really, it not only, as I had said earlier, it has everything to do with the 2-inch thick door, but it also has everything to do with where that vertical axis of pivoting is. So the closer it gets to the jamb, the more breathing room you're going to really need. So we get into trouble really fast with this. So hopefully this was a way to illustrate what's happening here. Let's continue with the video.
Like, it's basic, because I don't want it to swing both ways, just one way.
Right.
And so I was going to put a strike plate on the, it's complicated, but on the inside post on the left and the inside door on the right, because it's going to swing inwards on the big side. So I can easily attach weather stripping to that and not have to have it inside the, inside the jam.
Mm-hmm. There's another roller latch that you should take a look at. If it's 593-626.
So I looked at some. Match with angle stop. Go.
So that may not be ideal, but it incorporates the stop idea.
It would make it stop.
Yeah, you would really want that in the jam post though, and then the strike would go on the edge of the door. The problem with that is generally what you might want to consider doing is mounting that up at the header and on the top of the door, because then nothing is encroaching into the clear opening width of the opening. You
put that in the header.
Yeah, that's where that's normally installed. People want to do center hung pivots in a closet door, but they can't have the door swing into the closet because it's single acting only. Yeah. So that's what that one's used for.
Oh, and that could stop it where I want it too.
That'll stop the door for sure.
Huh. Well, that's a cool one with English. Okay.
Are you planning on doing access control on this? Any sort of electrified hardware?
Now, the reason I've asked about access control is because now is the time to do it. You're not going to want to try to run wires later. So let me just show you what I would have recommended to the client for this application if the answer was yes. Okay, so what I like is, I like a lot of things. SDC is the item that comes to mind most typically for me. Link to their website. Electric deadbolts. Now what's cool about this is, yeah, you can do an electric deadbolt. Right there. In the jam, wiring to the jam should be no problem. Let's see if we've got enough room, however. Oh yeah, definitely enough room. 1 3/8. Yeah, electric deadbolt, mount it in the jam or up in the header. It has a ball switch, and that's going to allow the circuit to close when the door's in the closed position, meaning it won't try to block or drop that bolt until you're in the closed position, because that ball will be pushed in or depressed when it makes contact with the strike. That's how this would work. Now you can also do this type of concept in a key override. Let's look at this, extra narrow. Okay, really the same dimensions. Okay, so Great. Now, let's take a look. I'm not finding on their site what I want. I'm wondering if it's been discontinued. But I'm assuming that it hasn't been. And what I'm trying to get after okay, I found it. I had to look up the part number. What we're talking about here is this. I wouldn't necessarily install it upside down, but back on their website, what we're looking at here is the 1291, and here it is. Yeah, so I would install one of these, electric deadbolt with a key override. Now, the client doesn't want key override. They want no security at all. He's literally thinking about a bolt just to keep, I imagine, the door in the locked or bolted position with thumb turns. So you could easily, and this will be discussed, and I'll just cover it now. So rather than threading a cylinder into this, or a double cylinder as you see here, so this is an electric deadbolt. Fail safe or fail secure. It works either way. Access control can be a card reader, whatever it's going to be. In case of a power outage or an electrical failure or something, the key or the thumb turn will retract the bolt, is all it does. Okay. Now let me show you what I would consider a typical thumb turn. Here it is. This happens to be a handicap compliant thumb turn with this having a larger handle, but it's a cylinder. Now you know what, I definitely wouldn't use this in his application because of the constrained space, so I would be using a standard thumb turn. Okay, install that where the cylinders would otherwise go, and you're in good shape. Now the same concept with these thumb turns is what's going to govern when we get to it, because I know that we'll talk about it again, with this Adams Wright MS-1850S that I mentioned. The MS-1850S, you're going to be able to do a back set on this of 31/30 seconds. So the edge of the lock to the center of the cylinder, you can do basically 1 inch, or 1 1/8, or 1 1/2. So centering it, it may work at 31/30 second. A couple of mortised thumb turns, as I just showed earlier, and you'll be as right as rain. All right, let's move on with the conversation.
No.
Okay.
Because it goes into my front door is all, that's all. I got my front door there. This just goes into my patio, my porch.
Okay.
I have like an atrium porch. That's what my wife wants. So I'm enclosing it in glass, thus the glass door. Which glass is surprisingly cheap to put it versus like windows.
What glass are you using?
What was it? 1/2 inch tempered.
Where do you live? I mean, what climate?
California. Super good climate. I don't need it.
Yeah.
It's not, and yeah, it doesn't need to be like temperature controlled. It'll be, and the sun is really good where it is. It's a good place for an atrium.
Why? Yeah, you could get by with 3/8.
Maybe it is 3/8.
Okay.
They gave me a bunch of choices, but it's really, and it'll be basically a glass wall fixated on the floor and ceiling, on that header, the same header that the pivot hinge is going to go in. That'll have clamps basically for the glass on the floor and ceiling, and then they'll be glued together.
Yeah, it's going to be awesome. Yeah, 1/2 inch clear tempered is, yeah, it's not cheap, but you can spend more money.
But windows were so expensive. So like compared to just windows and framing it and doing all the stucco, we live in stucco, and that was going to be more expensive than it is just to have glass installed, which is interesting.
and there's no concern over impact, missile code, earthquake code.
No, because
Okay.
it's exterior, like it's not a weight bearing. It's on a patio, so
Okay.
it doesn't have to be interior at all. It's outside of the structure. They said. So I'm like, okay, yeah, really interesting.
Now, in terms of locking the door, the idea of putting a deadbolt into the jam post because you've got more room, fine, absolutely. There are locks, though, that are used in the aluminum storefront industry that would work here because those aluminum doors are always very narrow styles. And
So I don't want to really lock it. I would do a double thumb turn for the lock, so you could open it either side.
Okay, so what you could do is you could use, well, whatever is going to fit, obviously, into the back set, into the space. But a part number for a lock, and you could just put not cylinders, but you put mortise thumb turns. You could put a part number MS, as in Mike Sierra, 1850, S as in Sierra. And then when that comes up, scroll down about 2/3 of the way down, and you'll see some lock bodies there.
MS 1850S.
Yeah, S as in Sierra. So, those things are going to work because they're very narrow back set. And you want to think about the cylinder that you attach, the thumb turn, the mortise thumb turn, that you attach there. You're going to want that to be balanced in the 2-inch width of the style as best as you can.
Yes.
You want to make sure that when the door comes to the closed position, the face of the thumb turn isn't in conflict with anything that you've put on the jam, so that it's not going to hit something.
Yes. So the face of the thumb turn has to be less than 2 inches, basically. Is that what you're saying?
Absolutely. Yeah, for sure. But if you were to select, they've got the standard bolt. You're probably going to want the hook bolt version because it projects a shallower amount. And the thing is, you could fit that into the door, so it's in a more traditional location. Plus, how thick is your jam post going to be?
It's the same. It's 2 inches.
Oh, okay, 2x2. Okay, yeah. So you won't need special cylinders, special mortise thumb turns. So that's one way to do that. There are other ways. There are variations on this, but this is a relatively inexpensive way to do it, and it's quite secure.
But these ones can come in double thumb turn?
Yeah, rather than the key cylinder you see there, all you would order for those would be a thumb turn style is all it would be. Thered be no key. It would just be, you're only throwing it just to, so what's the point of bolting it and having the roller latch?
I wouldn't do both. I would do either.
Okay. Yeah.
And it'd stay open much of the day, so it really wouldn't matter that much.
So what's going to control the wind grabbing this bad boy and making it move?
The deadbolt, or that's what I'm planning on making it controlled. When you want to close it, you bolt it closed so the wind wouldn't close it, or the wind wouldn't open it.
But you're not concerned about it being in the open position and having the wind push it?
I'd probably put a little bit of if it was open, I'd have to prop it with something, a pot or something like a plant or something like that.
Okay, so that's not super elegant. There are pieces of hardware that will address that as well. And this hardware, if that's not a major concern about that, you could also install a door holder, something that even is magnetic, that you can put the door to 90 degree and leave it there. Just park it so you're good.
I could do that in the floor too. Make a magnetic stop in the floor. I've thought of that too. Yeah. And I probably will do that because my wife will be like, "Hey, it's going to hit this."
Well, yeah, you don't. Yeah, doors, they have to be controlled.
It's going to hit the tree or the plant that she's planting. That's what it's going to be. The situation.
Yeah. And
So.
and also when you build this, make sure that there's absolutely zero possibility of contact between the glass and the steel. It has to be thoroughly glazed, with some means, 1/8 thick closed cell neoprene, some sort of material. That
they
glass,
put down like some weird latex thing in between the steel and the glass.
well,
It's like this stick. It's like a tape almost.
okay, it's not coming out of a tube. Okay, I would say
No,
that's
it's like a tape that they put it down. Like, yeah, I would think like a neoprene tip, but they have this like tape thing. Yeah, he said it's fine, but it's about 1/8 of an inch is what they said.
fine. Okay.
Mm-hmm.
Yeah.
So I would be interested in doing this. How do I order this deadbolt to do double thumb turn and matte
Okay.
black or something? And like, there's no picture of it on this thing. So
what I'll do is I have your email in front of me. I will send you an email with the items that we've discussed.
Yeah.
And
then if you have any ideas for weather stripping, I mean,
Oh, yeah.
I will take that because we just want it black, because I'm painting the door black.
Yeah, I'll get that tossed into an email. The absolute important part is that you get the vertical axis of pivoting right, that the header is prepped in the right position. You're going to drop a plumb bob down, and that's where you're going to place your bottom pivot. And that's if you get
don't
that right,
waste the left side of the door.
Don't worry about that.
Okay.
Not at all.
It's going to be awesome.
So that's not me making it up. That's me asking the same question of the factory many years ago, and I got a very clear. And the person who answered my question, she was Lynn. I forget her last name. No, not Lynn Rosenberg, but a gal, a lady, an engineer who was in charge of design and application for Rixon, and she said, if our catalog says that we're specifying this for a 4-foot by 8-foot opening, and you've got a 6-foot wide door, and you're well within the weight range, just move your pivot point over, and we're fine with that. And it's because they know it's going to work perfectly.
Okay. I mean, I was like conjuring up some because you can never bounce it, like some hole in there where I could drop BBs in to make it like balance. I was just like, how can I do this? And it was no
reason to make it any heavier. That's for sure. Because 300 pounds is it's going to be heavy what you have. The glass. Yeah. I've done projects with 1/2-inch tempered glass. I actually installed a late 60s hi-fi system from the ceiling of the room, and I dropped threaded rod down from the ceiling joists. So I've got 4 8-foot lengths of 5/8 threaded rod, and then from the bottom up, I had my glass guy give me 1/2-inch glass, and he drilled holes for the threaded rod, and I slid it all the way up, and then ran nuts from the bottom all the way up, and I had like 10 shelves. I got a picture of it somewhere. If I can find it, I'll send it to you.
It's so cool. Yeah.
Yeah, but 1/2-inch glass that stuff is, just don't twist it. Don't twist it and let it touch metal, and it'll last forever. Because, shower doors are made of 3/8, and if you walk, like if you're in Manhattan and you walk in any of those shops, that's all 3/4-inch glass. So that stuff is super durable.
3/4, that's heavy. Well, yeah, we'll see how it is. It's going to be awesome. Okay, so send me, I don't know if the cast strike or the roller latch is going to be what I want to do on this, just because it will be so much tooling for my steel guy to have to do that, whereas in a deadbolt I can drill basically 4 holes and not have to do any mounting. It'd be a lot easier to do it that way.
I agree. I mean, the upside of a roller latch is that you're going to need an auxiliary stop, and I'll put one in there so that you can push the door to the closed position and then bolt it with your thumb turn.
Yes.
The roller latch, you still need an auxiliary. You need an auxiliary stop because you don't want someone to push the door in the wrong direction and it start to, weather stripping is not a stop. It's not a door stop. Even though it can be used as a door stop, you don't want it to be the means to stop a 300-pound door.
That was what I was initially going to go for. I'll just put a ton of weather stripping and it'll stop where it is, but no, that won't work. I don't like that. And I will weld to, like I said, to the frame and to the door, these little basically stops on the inside. So, yeah.
Okay.
So
Yeah.
those will be, so it will actually stop, and then it'll look the same color and welded on, so you won't be able to really see them so well.
Yeah.
I'm gonna
put it up at the header if you can. You know, you don't want to...
You don't want them in the middle, do you?
No, well, you know, I've walked through openings, and I got my, you know, like 35 years ago, I was given a Rolex for Christmas by my parents.
Oh.
And sure enough, man, I cracked the crown on it, the sapphire, I should say, on projecting hardware, and it was like, dumb. You know what? You know, just tuck the hardware back as best as you can. Get it out of the way. Actually, I'm going to send you something even cooler. I'm going to send you. You know what? Okay. If you were to search my site for the words precision lock, you're going to find an extra heavy duty magnetic catch. It's basically two large magnets, and they're the cool kids version of roller latches. So if you can figure out how to get these installed into your tube, your steel tube, imagine two pretty powerful magnets that you just bring close to each other, and it keeps it in position.
Then how do you open it, though? You have to overcome the power of the magnet?
Well, they're not so heavy that you can't push it open.
Because this is what I was thinking. I was going to put magnets under this weather stripping and then have it stop, but then I thought to myself, like, well, it's actually going to be really hard to push open if it's going to resist the force of wind.
Yeah, but the magnets in those cases are really, so think of your refrigerator. So we sell weather stripping like that. You know, it's for metal clad doors.
Yeah.
And that weather stripping, the strength of that magnet is only to keep the gasket touching the face of the door, but it doesn't really, you know, if you remove your weather stripping from your fridge, it would be easier to pull open, but what you have now is not hard to pull open. So it's the same idea.
I see. That's interesting. I didn't think of it that way. Fridge doors. Okay. That's great. All right. So, hey, where are you anyways?
I'm in Southwest Florida.
What? Everybody went, okay, Florida's cool. All right. I've been to Southwest Florida. That's the only place I've been to Florida, but it was in January, so I thought it was wonderful. And come to find out, it's not wonderful in July. That's what everybody says.
Oh, no. That's fake news. I love the heat. So we're in Naples now. It's not nearly.
Oh, yeah, that's where I went. I went to Naples. That's bougie place. I like that area.
Super nice.
It's like the Carmel of California is like Naples in Florida.
You know, with the exception of the fact that it is always more humid here, the weather's generally pretty nice. And, you know, it's not nearly as humid as the east side, like Fort Lauderdale. But yeah, it's definitely not awful here.
That'd be great. All right. Please send me things I would like to buy from you. If you give me that lock, that'd be awesome. And then we'll communicate via email. Is good for me on this, okay?
You call me at any time. I'm going to send you an email in the next couple of hours, and
Great.
I'll look for your review.
Thank you. Oh, yeah. You'll get any review you want from me. You'll get it. Thank you,
sir. Thank you, sir. Bye-bye.
Talk.
Architectural Builders Supply hopes you have enjoyed this program. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.